All right, please turn to this page. I know it might look a little different on yours. It's a page before the regular note. It says exploring the effect of h on the graph of y equals x minus h squared plus k. What are you talking about? Yeah, turn to your table. You should see it in a giant table. And when I switch to here, this is what you should see as one of your boxes. You're like, what do you mean by h? Another new letter here? I don't know how much we'll call it h, actually, but I'm just showing where it is. So when it says h equals 2, what I want you to write up in your equation at the top there, I want you to write, we're going to graph y equals x minus 2 squared. And if that's confusing right now, that's okay. That's why you paid me to come here today. That's what they mean. When they say h equals 2, they mean put a 2 in the equation there and don't put anything in for the k. Well, what if there's something in with the k? Yeah, I know. That's why we're doing this investigation. Don't worry about a thing. So the next one across the top, so just go across the top with me right now. And then h equals negative 3. This is the little quirky part I wanted to warn you about. It's a little confusing with this h, because if h is negative 3, your equation is actually y equals x plus 3 squared. Like, why are you making it confusing? I must tell you, I'm not making it confusing. There's something a little bit confusing coming, and I'm doing my best to survive it. Okay? So I'm just warning you about that. Do you need a set of notes? Yeah? Okay. And we are on, let me find the page for you so you can get right caught up. We are doing the investigation in the table there. Right there. Right there, right there, right there, right there. Okay. How many more in your table? There's only 4 in the table, right? Now, next one, they give you a k, but not an h. And again, if this is confusing, that's okay. I'm just showing you what they mean by that. When they say they give you a k but not an h, what you actually have is y equals x squared. And then the k goes out here. Why is the h negative and the k positive? Yeah, I know. I know. There's something weird going on here. That one doesn't have an h, so nothing in the brackets. Only a number outside the brackets. In a second, I'm going to review the 4 equations and give you, hopefully say a sentence that makes you go, oh, okay, I'm with you a little bit now. And the last one, the k is negative 3, so the equation we're looking for is x squared minus 3. Very confusing. Here's what I'm up to today. What happens to the graph of a parabola when we either put a number in the brackets, positive or negative? That's the first 2 examples. And what happens when we put a number outside the brackets, either add or subtract? So you might have thought I overcomplicated it. Now I'm trying to simplify it at the same time. You just have to believe me that there's something awesome coming, and then there's something a little bit like, what's going on? So here's what I want you to do. Get out Desmos and graph, first get y equals x squared. I'll do that much with you. Let's make sure we know how to do that. Bring up Desmos, and if you have a partner who has Desmos, that's fine, or you can watch me. I'm going to do it. And you just type in y equals x, and to get squared, you need the little, it's called a tilde. It's over top of the 6 on my keyboard, on my computer, on your phone. Let me look on my phone and see where the exponent button is. It looks like a little top of house. Oh, you got nice buttons there, don't you, on your phone? You got a little one that says a to the b. And if you hit that, then you can do exponents. You don't need the tilde button, but I'm doing it on my keyboard. So I'll try and see if this keyboard thing comes up. There it is. You got this. So I'm going to go y equals and a little a to the b. I'm pressing this one down here. And a 2. Bang, parabola. Now, if you don't have that, call me over immediately, because that's what we're doing today. We're learning about Desmos as well. Do you have the graph y equals x squared? Does it look like this? Are you having trouble? Who needs help? I'm on the third one. He's like, I'm doing a different one. And you're saying, what? Yeah, okay. Anyways, leave y equals x squared up there. Then go on the line below. And what was the second one? We got to do it in brackets. Y equals bracket x minus 2. And then, you can just hit the squared button too. Now look at the red and look at the blue. Now, this is not mind-blowing. Do not look for some grand conclusion, some crazy thing. It's not that crazy. What happened to the blue graph when I put a -2 in there? How's the blue one different than the red one? It's moved 2 to the right. Okay? So that's what I warned you about. There's something really nice in this lesson. That's the one. Yeah? It's right 2. There's something really weird in this lesson. Why would negative be right? Oh, yeah, that's a good way to think about it, is that the exponent 2 flips it and makes it positive. It's sort of what's going on. I'll explain it a little more as we go along. But on your graph y equals x squared. So on your little page there, you're going to do y equals x squared, which looks like this. Yes? And then I missed that point, so I got to fix that. Ooh, giant eraser today. And these diagrams don't need to be perfect today, but give yourself an idea of what the parabola looks like there. Follow that 1, 3, 5 pattern. And then I'm going to do it in pink, because that's what I wrote at the start was pink. And what was it moved right to? Mr. Todd, did you bring us in today? Tell us it moves right to? Mostly. Yeah, sorry. That's. Maybe you're happy about that on a Friday, Mike. Okay. Come on, Mr. Todd. Nothing too tough today. It's Friday. My brain is baked. Direction of opening? Is it the same? Yeah, still up. Yeah, still up. Stretched or compressed? No. It's the same. Same width. Move left or right? Yes, yes. Right 2. But a little mysterious why the negative moved it right. Yes? And then moved up or down? No. This didn't move it up or down. And the vertex, can someone give me the coordinates of the vertex? 2, 0. Try the other 3, will you please? On your Desmos. Zip through it and draw the graphs. I'll do them up here. So if you don't have Desmos, then you can look up at mine as I go. And then we'll compare at the end, okay? So those of you on the video, I'm going to do it all but not talk. I'm just going to go through the steps very slowly if you're watching this on a video, or for anyone in class who doesn't have Desmos with a friend, okay? Maybe I'll talk really quietly. Y equals x plus 3 squared. Okay, back to Desmos. Watching the video, I'll do the conclusions with the class in just a second. For now, I'm just getting the videos, okay? We'll get the graphs on there. Next graph. X squared plus 2, but outside the brackets. I got one more to do. If you, and then I'll take up all the answers. So if you're not sure about any of the answers, I'm going to do it in just a second. Was it -3? -3, yeah. Do you need more time to get your graphs? Are you okay? Hopefully I took more than long enough, giving you a chance to fill in some of these. So, did you get, when you put a +3 in the brackets, did you get this situation? Yeah? Maybe makes sort of sense after the first one. Direction of opening, still opens up. Stretched or compressed? No, looks like it's the same shape. Like it's not wider or thinner. Moved left or right? Left 3. Mysterious, isn't it? Why it would go left 3 into the negatives when you go +3. Yeah. Moved up or down? No. And the vertex, I've got -3, 0. How did that go? Is that okay? Is it okay? More time on that one? No, that's okay. Then this one? Is this what you got? Hopefully you drew a better picture than me. Let's fight with the active board a little bit there. Direction of opening? Still up? Did you get up? Stretched or compressed? No. Maybe at first glance you started to go, boy, it looks a little thinner, but if you really look at it, it's not thinner. It's just moved up.
You go up, it's the same.
Yeah, if you look up far enough, it's following the same pattern. Good. Move left or right? No. Want the number out like that, it doesn't move left or right. It moves up or down. It moves up 2. That one makes a lot more sense. Adding 2 moves up 2. Yeah, that one feels good. The other one didn't feel so good. It was like, why is it doing the opposite? And we got to talk about that a lot, why it's doing the opposite when it's in the brackets. And then vertex, I get 0, 2. Did that go okay?
Yeah.
It's good? And the last one, did you get this look? Yeah? Direction of opening, up. Stretched or compressed? No. And again, if at first glance you thought it was stretched a little bit outwards, just scroll down a little bit and zoom in. You'll see it's the same shape. It's just moved down. Move left or right? No. Moved up or down? Down 3. And the vertex now is 0, -3. Well, I hope you're sort of excited. That was neat how that all worked out. And not too difficult either. Hopefully it's not like, okay, well that's not too mind-blowing.
Can you make a heart on decimals?
Can I make a what? I don't know that I can, but I can do this. Here, he's challenging me to do something fun on Desmos. Here, watch this. Try this on Desmos. Delete them all, and change it to y equals x squared, and then go plus, and just put the letter k. It actually doesn't matter what letter you use, but we'll use the letter that's in the investigation, k. And it says, add a slider. I'm like, hey, just like when I'm at the restaurant. Always add a slider to your dinner, a little hamburger, right? So add a slider here, and then watch. You can graph it up and down. Really going, I totally see it. Move it up and down. It gets better, friends. Do you see the little play button over there? Press play and watch what it does. It goes, hey, da. Oh, I got to zoom out a little bit. So where's it going? It's like, Afro circus. Okay, stop that. Let's do one like this, though. y equals x minus h. Why is it minus? We're trying to deal with the fact that it's going the opposite way, you know? So we'll keep talking about that. Let's not let that distract us here. Add a slider? Yes. Oh, x minus h. I forgot the squared. I can play with it. Left, right. Add a slider. Make them go at the same time. He's a step ahead of me, folks. Here, y equals x minus h squared plus k. Activate both sliders. Whee! Yeah, right. Okay, wait. We're not done. Let's bring in yesterday's. Y equals a. Remember a? X minus h squared plus k. Add sliders? All. Yes, all the sliders. And let's animate them all. Here's the whole chapter coming at you in one animation. Let's just sit here and watch this. Here's all the parabolas. We can move them left. We can move them right. We can stretch them. We can flip them. And now you're ready for glow dance. Yes? Yeah. All of that is very fun. But remember, it's all there when you're doing your homework to go, wait a minute, did I get this right? Do I have this? Is it okay? Bang, Desmos is there to help you out. Can't have Desmos on the test, though. By then, you got to know what you're doing. Yeah, but this will help. Can you please switch to the regular note, which I hope is going to go so fast now. You're like, I totally get that. There's one little thing to worry about, and we got to talk about it a little more. When compared to the graph of y equals x squared, the graph of y equals x minus h, why is it minus in there? Just to deal with this right-left thing, is a parabola that is shifted horizontally. Horizontally is the word we'll use there. Either left or right. Is that what we saw? Yeah. Putting a number in there, either moved it left or right. If it is truly negative in there, it moves right. And it is okay right now if you're, oh, can I make a thinky face? I need a face that goes, I need one of those emoticons from your phone. It's like, Here it comes. Here's my best chance at it. It's weird. Why would it move right? Same here. When it's a positive, it goes left. Mysterious. We saw it happened. I don't know if we're ready to explain why it's happening. Well, maybe I can here, actually. My Just Dance example. If I play Just Dance with my daughter, and you people watching on the video, good luck understand what I'm doing. If she's standing right in front of the screen, and she's great at it, right? Have you ever played Just Dance with somebody who's incredible at it? They're just up there and they're a step ahead of the whole thing. Now, I'm standing over here to the left of hers, yes? And I'm looking at her to see what she's doing. I'm actually looking right. I look right to see what she's doing. I'm doing the same thing. But to you looking behind us, it would look like the dance had moved left because I'm looking right. All right? So that's just let that rattle around like a marble in your brain all weekend. That's not a great explanation. We talked about that in math, right? Some things in math I explain it and you're like, I get that, I get that. Some things in math it's like, cling, 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 cling. What did he just say? Okay? That's why that's so complicated. Just talk, can I just memorize it? Then I'll be okay? Well, yeah, but we'll explore it as we go along. When compared to the graph y equals x squared, if we do y equals x squared plus k and put something outside the squared, the parabola is shifted vertically. There's our big word for today, vertically. Either up or down, but this one's much nicer. This one makes more sense. If it's plus k, it moves up. If it's minus k, it moves down. That one's nice. We like vertical. Okay, one more marble to bounce around your brain. The reason this is happening algebraically is because the h is on the same side of the equation as x is. It's right with the x. The k is on the opposite side of the equation of what y is, so they act differently. Another marble, just let that roll around like, oh, this looks like it's set up perfectly, but it's set up sort of weird that the h's and k's aren't right with their respective x's and y's. But we don't need that right now. We don't need any of that right now. I just didn't want you to leave on Friday and think that there isn't ways to explain this. For now, all you need is, okay, negative right, positive left, inside the brackets, positive up, negative down, outside the brackets. That is plenty, like plenty for us today. Okay? So here we go, example 1. If we were trying to do y equals x minus h squared plus k, and the parallel moved 7 units left, would that affect the h or the k? If we're going left or right? H. So value of k, there is no value of k if we're moving left. Now, will h be positive or negative? I'm going to put positive 7. And I'm going to tell you, very scary column. I like this column better. This is the column you need to be able to do, is write the equation. We go y equals x something squared. If it's going to go left, is that going to be positive or negative? Positive to go left. The opposite of what we would think, right? You'd think left would be negative, but we found out it goes opposite, positive, which means that the h is negative 7. But please don't let that, if you're like, I totally get the right-hand column, you're in great shape. You're in great shape for grade 10, for grade 11, for grade 12. You just need to know what the equation looks like. But technically speaking, the value of h in there is a negative to make it positive in the brackets. Let's not get sidetracked by that, though. But if you have a question,
Would it be wrong to say, like, y equals x minus 7?
No, it wouldn't be wrong to say that, just a little untidy.
Yeah.
Okay? Yeah, good. Let's do an easy one before our brain gets hurt here. 3 units up. Does that affect the h or the k? K, and that's a positive 3. There's not much to think about. Vertical is nice. There's no h in this one. And so it's outside the squared, or it's outside the brackets. I know there's not brackets in that one. That's why I said it's outside the squared. But sometimes there'll be brackets and that'll be outside. All right, how about this one? 2 units right, 5 units down. Let's go to column 3. That's the one to go to. Can I write if you can do column 3, this is all just details. Okay, y equals, who wants a shot at this? The two numbers, if we're going to go 2 units right and 5 units down. Minus 2 to go right. Did you memorize it or do you understand it at this point? You just went, yeah, I think for now we can just memorize it. Negative goes right. And then what did you put out here? Minus 5 to go down. Yes? And then the k is easy. That means the k is negative 5. But the h then would have to be positive 2. Okay? But please, please don't let your brain blow up about the h. That's just us trying to write it in a textbook and going, keep in mind, the h does the opposite. If that's all you take out of it and goes, all this means is the inside one does the opposite of what my brain would say, that is plenty for now. That is really good for now. Okay? Is that okay? Well, I'm just going to keep doing that now. I'm just going to keep doing that in different ways. I gave you the description, and I made the equation. Next one, I'm going to give you the equation. We're going to come up with a description. 6 units up. So again, those 2 marbles I've dropped in your brain that are rattling around in there, if you knew it was 6 units up, you can forget about the marbles for now and go, well, I know what's going on. There's something deep technically happening here, and we'll get to that. What do you like here? 2 units -2. To me would be left. That's what my brain tells me. It's the opposite then. It's 2 units right. The one inside does the opposite. So, 1 unit left. And I just didn't hear you, 4 units down. The outside one. And this is going to be true in all sorts of functions we look through at high school. The outside one's always going to be like what we expect to happen. The inside one's always going to be the opposite of what we expect to happen. Questions there? What do I got left? I got to make some graphs here, don't I? Yeah. Equation to graph. Yeah, equation to graph. Here's the steps. I'm going to sort of jump ahead a little bit. I don't think you're going to have too much trouble with this. The 2 things you're going to want is the transformations and then your step pattern. And that's, well, it's not jumping ahead a little bit. It's bringing in yesterday's, no, yes, it wasn't yesterday, what was it? When did we do it? Wednesday? It's bringing in Wednesday's note to here. The transformations, vertical up 3. I'm just starting to add some extra words, okay? Some extra words. You can write up 3. I'm okay with that. But I'm adding some words that we're going to need along the way. So vertical up 3. Step pattern. Is there an A value out here to worry about? No. So it's just 1, 3, 5. And maybe you're like, oh, I totally get where this is going. We identify where the vertex is by going left, right, up, down. And then we just use our step pattern to go from there. So here's the step pattern, because a couple people need some clarification on that step pattern. There's the vertex. And the step pattern tells you the steps you go, how much you go up each time. So the first step is up 1. Then the next step is up 3 from there. And this up 1 on this side, and then up 3. So it's always from the previous point. Then you can draw your parabola. So down here, transformations. And here's your big moment. If you get this transformation, then you've handled the curveball of this lesson. This is the curveball. The +2. Is that left or is it right? Left. And a lot of people, they do this, even in like grade 12. They see the +2 and you watch what I do here. They point right because they go, +2's that way. Oh, wait. Horizontal is always the opposite. Yeah? So it's okay if you're thinking like that, if you're sort of thinking right then left, okay? So left. Oh, so I'm going to write the extra word here. Horizontal, left 2. Step pattern. Is there an A value here? 1 through 5. Okay, so we're just 1 through 5. But I'm just getting you ready for it. If there is an A value, we can handle that too. We've got that in our bag of tricks. But this lesson sort of goes, let's just make them all 1 through 5 and focus. So left 2, there's the vertex. But just in case the step pattern, you sort of get the step pattern, but not really. From there, you go over 1, up 1. Then from that point, over 1, up 3. Then from that point, over 1, up 5. It's truly a step pattern. It tells you how big each step is as you go. Yeah. 1, and then the other way, 1, 3, 5. You have the questions? Do you have the questions?
How do we tell if there's like an A value?
Oh, let's say I did this exact same equation, but decided to give you an A value. Maybe it would look like this. It would have an A value out front. That would be the A out there, okay? One more? One more time? Oh, one with 2 in it. Ooh, really tough. But again, let's get in this habit here. because I think this is where you're going to want to be. Transformations and then step pattern. Write one. I'm going to write the whole fancy way to write it, though, okay? Just so if it does it in the homework, you're not confused. They might write this. They might go horizontal translation. What do we decide? The -1? Is that right or left? Right. And then vertical translation up 5. Step pattern 1, 3, 5. But I'm doing that so that we're ready. If an A value appears, we're like, not a big problem. Yeah? So vertex is over 1, up 5. And then step pattern over 1, up 1, over 1, up 3, and then it goes right off the page. Can't get any more points there. If you're doing it on graph paper in your homework, maybe you can get an extra couple points on there. But the grid I've got, I can't.
You can get more points there. Just draw
Yeah, I could go off the page there and just say somewhere about here. Questions about that?